Okay, so another test tomorrow. So it's pretty much like the last one, and the topics that will be on it are essentially, it's going to mostly be on loops. So the idea is it focuses on the stuff since the first one, and so primarily loops. There could be something also about random numbers. And then possibly something with images, so like we did the picture bitmap stuff. So like modifying images. So those are the only topics. So indirectly, you would have to know the stuff from the first week, or you have to know how to make a variable, for example, to control the loop or to set the random number. So the focus isn't on that, but you have to kind of know it to be able to do the stuff from these topics. So today's stuff about classes and methods is not going to be on there, but so focus just on these three. I'll probably make it a little bit shorter than the last one. So the last one was a little longer, I guess, than I was intending it to be. So probably like one question shorter or something than the last one. Okay, so any questions? So just a reminder, if you haven't turned in any homeworks yet, you should probably get started on those. And then also, I have some of these exam ones to turn back. If I didn't give you yours back yet, I'll give it to you right after I lecture part. And then you're supposed to fix the erroneous answers and hand them back to me. Okay, so if there aren't any other questions, then what I want to talk about today is to introduce classes. And really, this is a way you can design and organize your code more efficiently. It does make things more complicated, and so like as we add more and more topics on, your programs can get more and more complex. And so the idea behind classes is it's really a design kind of choice. So you can make an analogy to like designing a city, for example. You could just sort of build on stuff on the city and roads and buildings as it happens. Or if you had some vision about how things should be organized in the city, then you could design stuff for future expansion and have higher traffic volumes or whatever. And so it's kind of the same thing here with programming. With classes, we have a kind of a new way we can design our programs that can make them potentially be easier to write and potentially map nicely with the thing you're trying to solve. But also you could also use these constructs in a more complicated way that could actually make things messy. So it kind of can go both ways. You could use them in sort of the wrong way and get really ugly programs. Or if they're used the way they're intended, then in theory it should make your programs nicer and more efficient and possibly could scale up to millions of users or whatever. So the idea behind classes is we have an analogy kind of with the real world. So the idea would be, just to give an example, let's say we're trying to do something with, how about like students and courses. So let's say we're trying to have some computer system that can enroll students into courses, and then you'd have professors. So it's kind of like a whole educational management system. So if we wanted to build that, like you wanted to build UA Online or whatever you use to go get online and sign up for classes and keep track of that, then in the real world, the idea is you could model this where you'd have students, and then, well, what would you need to track about students? Each student has like a student ID, for example, and probably want to keep track of their name and email address and whatever other things. And so the idea would be you'd kind of keep track of all the stuff that you'd want with an actual real student. And then you could have, you probably would have information about individual courses, so like CSA110, and you'd have so that'd be the CRN. I guess I should just say the course, how about just say subject? And it would have some CRN number and a title. It'd have like who's the instructor. What you might do if you take like a database class that kind of relates to that, you might decide to have like all the students in the class listed here, or you might decide to put them somewhere else. But maybe you have like the students here, like students enrolled. And then you probably also want to keep track of instructors. So you have like the instructor ID and name. I don't know what else you'd want, like their rank or something, office, whatever. So we'd want to keep track of like these 3 things, and then probably a lot more. But the idea would be, if these are the entities you would have in the actual world, then what we can do with classes is we define objects. So a class is short for classification. And like on the first day, we said Java is an object-oriented programming language. And so what that means is in Java, we can define objects that correspond to like these things in the real world. So we can make a Java program that has all 3 of these things as objects or classes. And after we define these classes, then we can write code that ties them together however we'd like. And what we've got here is like the blueprint for the objects. So this is like the design or the blueprint. But at this level, we haven't specified actual faculty or actual students or actual courses. It's just like the fields that would correspond to a class or to a student. And so the other part that we would have in the actual like Java program is we would make instances of the object. So this is our terminology. And this would correspond to actual entities. So we could have, this is where we'd have like a variable, and so we could have a variable called whatever CSA110, and then the CSA110 variable could correspond to an object that's a course. And then for that course object, we can set whatever these fields are. And so in this case, the subject would be CSA110. And then whatever its CRN is, I don't know what it is, 3-1. And then title, instructor, and so forth. So this would be like one variable, and then it's going to reference like a course object that stores the specific information for that course. And then if we're following this model, we would have an object for every single student. So like all of you would be an object, and then there'd be like whatever 20 variables of type of students. So it'd be like 20 student variables. And each variable would correspond to a different ID, name, email address. So sort of the principle behind object-oriented programming is take the entities you have in like the real world problem you're trying to solve and then map them into these objects in the Java program. And then and then we would create instances of the objects that correspond to the actual people or things that you have in your problem. So sometimes it's easy to get confused between the instances and the class objects. And so the class objects are like the design of the instances, and the instances are the actual things you've got. In this particular case here, we've modeled kind of like real world things that exist, at least in principle. So, you know, for students and instructors, they're actual people. But you can have virtual kinds of things like a course. There's no physical thing that's really a course. It's more like an idea. And so you can also model these abstract kind of concepts in here instead. So that's the high-level idea behind how classes will help us in terms of modeling the problem and then piecing them together. So having said that's like the kind of the bigger picture about what this does for us, let's kind of dive into the specifics about how you define like one of these class objects, and then we'll spend most of our time today like going over like the details of just piecing together a class and not really saying much about the bigger design goals. Okay, so any questions so far? Okay, so we could have like one student class and then hundreds of instances of the student class corresponding to every student that exists. All right, so we've already made classes because Java forces you to make one to write a program. So when we've been writing public class whatever, hello, then this is defining a class called hello. And so far, we've been putting all of our stuff into main, or mostly, not everything. So here, we've got all this stuff. So our terminology is that this is the class, and then this thing over here is called a method. And the method is essentially some action or chunk of code that is supposed to operate on the class. So if we were doing something like this, we could add methods in here like, well, let's see, how about if we add one course? So we could make a method on the course class that says like get number of students, and then it might do some computation to tell us how many students are enrolled in the class, or calculate average GPA or something. So we can make methods that are supposed to operate on that particular object. Having said that, you could kind of abuse the idea, and you could make a method in here that has nothing to do with a course. You could make a method that says compute the square root. And you can do that, but just from an organizational point of view, it kind of doesn't make sense. Okay, so we've already been making classes, at least one class, with one method, the main method, which is where our program starts running. Okay, so once you have a class to create, so this is once again like that blueprint for an object. To actually create an instance of it, this is where we would use the name of the class, like this could be somewhere else. You have the name of the class, like hello, and actually what we've been doing so far is we've been sticking it inside the same class, but it can go somewhere else. In fact, normally we'll end up putting it in a different place. Maybe I'll even do this. Let's say I have another class, public class. And you might notice this is what NetBeans does for you. When you make NetBeans, it makes a class called main. So you could have a separate class called main. If you have a class called main, this would be in the file main.java. This would be in its own file hello.java. So we've already been doing that with the class name matching the file name. But if you have multiple classes, they would be in separate files. So let me get rid of the main here. So for now, ignore what might be inside here. If you want to, so this defines the blueprint for hello. If you want to make an instance of hello, then the way you do it is I need to be in like a main, I guess. So the way you would make an instance of this is you use the class name like the data type. So just like we've had int or double or string, instead you use the name of the class you want, like hello. And then you pick a variable name, and I'll just call it x. And then when you want to make an instance of it, you set it equal to a new, and then you give the class name, and then left and right parentheses. So this is the line of code that says create an instance of the hello class, and then you could start using it. So we've already been using this. So we've been using like the random class, for example. And so when we do that, it makes an instance of a random object that lets us generate random numbers. And we've been using it for the scanner. And so when we do this for the scanner, it makes an instance of the scanner object, and you can use that to start reading stuff from the keyboard. But if you define your own class, then the way to start using it, you make an instance of it first, and then we can start using that class. Okay, so let's say a little more about what goes inside this class, or inside a class. So you substitute whatever you want your class name to be, and it should correspond to what the class actually does. So, if you're making a course class, then it should have course stuff in it and not something else. You can define variables up here if you like. And you define variables the same way we've been doing it, except you stick the word public or private in front. So, for example, you could say public int course num or something. And so the idea is these variables would correspond to fields that match whatever this class is about. So this is just an example. Or you could say public string title or whatever. So whatever variables you might need that correspond to fields that would be relevant to whatever the class is, you would normally define up here. And these variables exist inside the class. So anywhere inside these curly braces, I can use these variables. If I have the word public in front, then I can access them from outside the class. And so if I've got public over here, then say outside here in main, it's to access these, I use the variable I've got right here, and then a dot, and then whatever variable comes after it, like course num. If I stick the word private in front, let's call it, then this variable something I can still use inside the class. The idea is it's private to the class, but I wouldn't be able to access it from outside. So from outside this class, if I tried to say x dot something, then this won't work because it's listed as private. So that's the difference between putting public in front or private in front. Is public you can access from outside of it, private you can only access inside of it. So we'll say some more about why you would want to use one versus the other later. But in general, some people recommend that you always put private in front of your variables. And so we'll say more about that coming up here. Let's see here. Okay, so we can put variables here, and then we can define methods. We've seen a couple methods already, like we've been using public void paint. And inside that was where we draw stuff, and so that's the paint method. But we can, and we've used main, and then we had a couple others, but we can define our own methods. And then the structure for defining them is you use public or private, whichever one you want. This new thing that's going to be the return type. And then the name of the method. And then inside parentheses, a list of parameters. And then you'd have curly braces for the body of the method. So we'll say more about this coming up here, about how you define these, but you can put as many methods inside the class as you like. So these methods would do some kind of actions or have some kind of code that acts upon these variables over here. Okay, so what I want to do is start with like the simplest kind of class possible. So I'm going to go and use NetBeans for this. And I guess I have to update it. All of these things that we just talked about are sort of optional, and so in the class you could put as many or as few variables up here as you like, and as many or as few methods as you like. And so here I'll make a project, and then I'm going to start with like a really simple class that has just variables but no methods at all. All right, so here I'm going to make a new project, and I'll just call it class, Java application. And I'll call it class example. How about I'll call it class intro. So if I leave that box checked right there, then let's see, here's class intro. So it goes and creates a class for me already called class introduction, and then adds a main for me. And so let's make a new class, and in our example, let's have it track like some amount of money. So you want to have a class that represents some monetary value, whatever, $10.33 or something. So here in NetBeans, I can go and if I click here on, I'll click here on this class introduction, and then if I right click, I can say new Java class, right there, or I could also just click on this plus right here. There's another way I could do it. If I do that plus, I could go pick Java class over here. So I have like a couple ways you can make a new class, but for whatever reason, I like to right click right here and say new Java class. And then we pick a name for the class. In this case, I'll just call it money because it's going to store some monetary value, and say finish. And here in NetBeans, it adds this package at the top for us, and then you have an empty class. If I wasn't using NetBeans, if I was doing this straight in text editor or Dr. Java, then I would just create two files, one called money.java, the other called class introduction.java, and they'd be in the same folder. And then you don't have to have anything for the package that could be left off. Okay, so the idea is this class represents some monetary value, and so we can do, one way we could do this is let's make a public integer that represents the number of dollars, and then another one that's the number of cents. So here I've just made a class that can store dollars and cents. And so don't forget, this is like the blueprint. So you're not limited to $1 variable and 1 cents variable. You get a dollars and cents for every instance of the money class that we make. So how do we make the instance? How about I'll go back to, let me close some of this other stuff here. I'll go back to the main class that NetBeans made for me automatically, or you could have made it manually. And we said you use the name of the class as your data type, and then pick some name for it, like M1, and set it equal to a new money and then left and right parentheses, semicolon. And I can go ahead and let's make 2 of them. So at this point I've made 2 separate money objects, and if I follow along here, so from these 2 lines right here I have an M1, and I'll just kind of draw a picture that represents the objects. So I have an M1 variable, and I created a new money object, and so I'm going to represent the money object by a box. And inside that money object, it's got a dollar variable and a cents variable. So there's a dollars and a cents. And then I made a second one, M2, and that creates its own money object. And then that other money object also has a dollar and cents variable. So there's 2 separate dollar and cents variables, one for M1 and one for M2. And then I can do, since those are public, if we go back here, I made both of those public. Then it's valid for me to access them from outside the money class. So I can say M1.dollars equals whatever, let's say 3 M1 dot, and here's where NetBeans is kind of nice. You know, you do the dot, it has the pop-up thing here, and so it reminds me that I have a cents variable that I can access. So I could set the cents equal to something 40, and I could do the same thing for M2, set the dollars to whatever 10. So I just set the dollars and cents values. So if I kind of follow along in my picture, when it runs this line of code, it'll set this to 3. When it runs the next line over here, it sets the cents to 40. And then when it gets over here, this dollars gets set to 10. It's 40. And then this cents gets set to 50. So sometimes when people are first learning about classes, and you look at the money class right here, some people think of this like these were local variables declared right there in main and think, oh, there's only $1 and 1 cent, but there's really 2 of them, one for each object. So the mistake that sometimes is made is to think that the dollars get set to 3, then it gets overwritten by 10, and this one was 40 and overwritten by 50, but you're not overwriting anything because these are really 2 separate dollars and 2 separate cents. And then, well, there's not too much we can do right now, but we could print them out or something. So we could just do a system.out.println of m1.dollars plus, I'll just make a space. So I'll just output the dollars, and the same thing for the cents. Okay, so if I compile and run this one, then it should, there it goes finally. So there it outputs 3 and 40, which is M1's dollars and cents value, and then 10 and 50, which is M2's dollar and cents value. So, we could have done an equivalent thing right here, where instead of making these 2 money objects, I could have just made like an int M1 dollars and M1 cents, int M2 dollars, M2 cents. And I could have set this one to 3, and this one to 40, this one to 50. So I could have done something like this. Instead of having these 2 money objects, I could have just had 4 separate integers that I manipulate right here. And that would work probably fine. So it's really kind of like a design choice. If you want to better represent this concept of money as an entity, then that's where the money object makes sense. But if you didn't want to do that, then you could just make separate variables. There are so with the money object, it's simple enough, you might just do it directly. But when you're talking about more complicated things like a class or like a student, like a course, where you have all sorts of different properties of a course, and then you start having lots of different courses, It becomes really messy if you were going to try to manipulate all of those variables directly. And it becomes a lot easier to just say, all right, here's the CS110 course as an object, and then that packages together all the students in it, the CRN number, the whatever registration fees collected, and all that stuff could be hidden or kind of packaged inside there. Okay, so the other thing I wanted to show here oops, is if I go over here, instead of making dollars public, I make it private. Then now when I go back to my class introduction, I have a little red line here because now I'm not allowed to access that variable. I was able to get to it before when it was public, but now that I made it private, it's inaccessible from outside the money class. So this is in the class introduction class instead. So now I get the error message, dollars has private access. If I tried to compile it, then it gives me error messages. And then also, if I do the little pop-up thing here, then you might notice that dollars has disappeared. And so NetBeans is smart enough to know which things we can access that are public and which ones we can't, which are private. Okay, so we'll say more about the public-private thing here coming up. In this particular example, I'll go make this public again. In this particular example, I just have two things that are integers, but you could add other data types, whatever you want. And so I could have like a string, or let's see, I could make a public string. What would be the term? I'm trying to think of like if it's US currency versus Canadian or something. So it could be like country, I guess. Maybe country's not the best thing if you got like a euro. I don't know what you call that. So you could have some field here that represents the country that this amount can store. I'm not sure what else you might want to store in the money class. You could, we'll do a better way to do this later, but you could also do something like, you could have like a type that could be like credit versus cash, something like that. So we'll, versus, I don't know, PayPal or something. So we'll have a better way to do this later, but the main idea I want to get across is you can have different data types here, whatever makes sense for the class. Okay. So let's say, that's just the simplest kind of class that just has some data variables in it. And even that can be kind of useful. But normally we'll have methods in here as well. And there are lots of benefits for using methods. And then here I'll just outline a couple of them. So the methods basically is group together a chunk of code. You can make a method that acts like a function. So for example, getting the random number, where if you had some random object and you can say ran.next int. So this thing is like a function. You give it an input of the range of numbers you want, and then it spits back out an integer. So here's your input, in this case the range, and then it spits out or returns an integer. In this case it's 0 to 9, randomly selected. So that's why this is like a function. We send in some input and get some value back out. And if you write your code in functions, it makes them reusable. So whoever wrote this code that generates random numbers, we're reusing it all over the place, but maybe it originally was used for something else. But this lets you write some code once and hopefully reuse it multiple times later. By doing this, it also splits your program up into smaller pieces, and that can help make your program more understandable. So your program becomes like a bunch of methods that each do some individual thing, and then you piece them together, and it's presumably easier to understand one kind of isolated method than how all that code would fit together without them. And then with all these things, it makes your program a little easier to debug. So debugging is generally easier, because if something goes wrong, what you can do is you can test each individual method to see if your methods are working. And once you know that one method is working, you can kind of move on to the next one. So it lets you kind of develop in little chunks and hopefully isolate down problems to specific methods. So there are various good reasons for making a method. And let's go over the syntax for making one. So you have your class, whatever. Maybe you have some variables defined here. To make the method, we said you use the word public or private. And there's actually a third one we'll talk about later called protected. We won't really use it much in this class, but there is another one though. Next you have the return type. So the return type is the data type that the method returns. Sorry. So in this example with next int, the return type's an integer. If I was using like next double, then the return type would be a double. And so it's just whatever data type you want the method to spit back out. If you don't want the method to return anything, then you can use the word void. And so that's why we have void in main. Main doesn't need to return something. So that's what void means. It's just like an empty placeholder. Then you have the name of the method. And then inside parentheses, any parameters that this takes. So these are like input values that the method needs to operate on. And the input parameters have the data type, a space, and then the name, or I should say variable name, and then a comma, and then that repeats however many parameters you want. If you have no parameters, then this is just empty parentheses with nothing inside of it. So in this example up here, this next int method took one parameter, that's the input range. In this case, the input range is an integer, but you could define it where it takes whatever you want as an input. All right, so once we have that, then we have curly braces, and then whatever code in here we want that does something related to the method. It can access these variable names that are sent in as parameters. So what you put in here would be kind of like what you've been doing so far inside the main method where you list all your code. And then when you're done, when it's computed whatever it needs to compute, then you can either just exit when it hits the right curly brace, or you could put the word return. If this is void, then you could just say return semicolon, and then when it hits the return, it'll immediately exit out of the method. Or you could say return with some value, and then this value has to match whatever the return type is. So if this is supposed to be returning an integer, then if this is an int right here, then this should be some integer value. And if this was double, it should return some double value. If this is a string, then it should return some string value. So the data type here has to match the actual thing that's being returned. Okay, so let's do a couple little examples to give you the idea. So back here in NetBeans, I'm going to make a whole new class. And my class is called foo. So it's not a very nicely named class. It doesn't, but it's just got test stuff in it. So, so here's a new class I made called foo. And just to give an example of a method, I'm going to have it have a class with just a method in it and nothing else. So we've seen like the two extremes, a class with just data in it, and then now here's a class with just a method in it. So here I'll say this method is going to return an int, and it's called max. So the idea is, here's a function called max, and what it's going to do is take two numbers as input, and here I named them num1 and num2, but you can name them whatever you want, and it's going to return back whichever one of those numbers is bigger. So the logic for this is pretty easy. We just use an if statement. If num1 is bigger than num2, then we return num1. Otherwise, return num2. So if they're the same, it returns the same number. So whatever values we send in for num1 and num2, this method will come through here, check if num1's bigger. If it is, then that's the return value. Otherwise, num2 is the return value. So let's use this class and this method in an example. So if I go back to the main method over here, and for now I'm going to comment out all this. And I'll put my new stuff at the top. So before I can use my foo class, I have to make an instance of it. And so I have foo, and I have to call it something. My foo equals new foo. And so this is something that is easy to forget. Sometimes there's a tendency to want to go ahead and try to use the class without making an instance. So normally you'd make an instance of it first. Once I have that instance, then I can call the method on it by giving the variable name and then a dot. And then here we can see there's this max right here that I just wrote. And takes a num1 and a num2. So let's just use this in a print statement. So I'll give it 3 and 5, semicolon, and I'll copy that and do it again. But this time I'll give it 325. And so what this program should do is first let's do this again. And so on this first line right here, it creates a foo object, and so I have a my foo that references a foo object. Inside the foo object, I have only one thing. I have a function or a method called max. And on this next line right here, we print out my foo with max, and then 3 and 5. Let me go over here and copy that code. Whoops. Okay, so we made a myfoo, and so it references this thing, and there's a function called max. And then when it actually calls max right here, and it sends in a 3 and a 5, so I should write that down somewhere. So here, then we do myfoo.max 3, 5. Then what Java does is it takes the first number 3 and it matches it up with the first parameter that's listed here, in this case num1. Let's make that bigger. And then it takes the second one, which is the 5, and it matches it up to the second one, num2. And so num1 gets the value 3, and num2 gets the value 5. So this is this idea that we send values in for these parameters. And then when this thing runs, now it'll check, is 3 bigger than 5? Nope. And so it'll come down here and return num2, which is 5. And so this whole thing gets replaced with 5. So you can think of it as everything that I highlighted right here gets gets replaced with the return value, which is 5, and then I'll just print it out. So this would print out 5. And then when we do the second one with the 300 and the 25, then it's like we have a clean slate. We redo this whole process where 300 gets sent in for num1, 25 gets sent in for num2, and then we know that the reason 300 sent in for num1 is because of the ordering. So 300 came first, and so it matches up with the first parameter. And so now when this runs, it'll say, well, 300 is bigger than 25, so it's going to return 300. So this whole thing right here gets replaced with 300, and then it's print out. So if I come back here and run it, then we get 5 for the first one and 300 for the second one. Okay, so that's the idea behind making these methods. In this case, it's not a real fancy method. But if I wanted to compute max a whole bunch of times, then one of the nice things is now whenever I want to compute it, I just call the method with the data. I don't have to copy and paste that if statement every single time I want to compute the max. So it reduces the amount of code we'd have to write, and we reuse the stuff that we wrote once. Okay, so the last thing I need to talk about before you work on this drill. So we'll say more about this tomorrow and also probably on Monday. But let's go back to this money class and talk a little bit about why you would make these things private. So if I change these to private instead of public, the advantage of doing this is I could make a public method to access these private variables. So here's going to be the idea. So right now you can't access dollars and cents at all from outside. So what if we do want to grant access from the outside? Then I could make a public method that lets us set and get the values. They're called mutators and accessors, or getters and setters. So let's make a method to set the dollars variable. So since I'm going to set the dollars variable, I don't need to have a return type, and I'll call it something like set dollars. And then I'll send in a parameter that's an integer for the new dollar variable, new dollar amount. And then all we'll do inside of here is say dollars equals new dollars. And so if I make a money object, then this will let me set the dollar variable by calling the set dollars method. And then if I want to get the dollars, I could do this. I can make a public method that's an int called get dollars. It doesn't need to take any parameters, and then all it does is it returns the dollars amount. So this pair of methods lets me set the dollar amount, and then this one lets me get the dollar amount. And then I could do the same thing for the cents. Before I do that, let me just go back to the main class over here. I'll come back to that one. So I know I'm kind of jumping around a little bit. Okay, so this was the original way we had done the money, dollars and stuff. And then since I made both dollars and cents private, I have all these squiggles here because I can't access them. But I can access the dollars indirectly by now saying m1 dot, and then I can call set dollars. And then inside here I could make it 3. And so that would basically do the same thing that this line right below it used to do. So I'll comment that one out. And then right here where I accessed m1 dollars, I can't do that anymore, but I can use m1 dot get dollars. And since it's a method now, I need the parentheses, but then get dollars is returning dollars, so I get the same effect. Okay, so, and then same thing on here. This becomes m2 dot set dollars. So here I can make it work with dollars by having that get and set method. And then I do the same thing for cents. So if I come back up here and basically repeat this for cents, public void get cents. And then I can also do the same thing for set, whoops, this is right, set, not get. So here I got the same thing, a way to set the cents and a way to get the cents. When you change something, there's a name for this, it's called a mutator. And when you get something, it's called an accessor. I tend to not to use those terms, but they're the Java terms for them. The mutator is also called a setter, and then the accessor is also called a getter. So once we have these, I can go back to my main and I could fix these up the same way where right here where I'd set cents to 40, instead I'd say set cents and then in parentheses give it 40. And same thing right here. That becomes 50. And then this one becomes get cents. Down there. Okay, so if I run this new version, I get the same output as before. And so what you're probably thinking is, didn't we just go through a whole bunch of work for nothing? Because the earlier version I had, where I just directly accessed dollars and cents, was a lot shorter, and it did the same thing. So the answer is yes, we did do a lot more work for the same thing, but what we've done is we can now add some more protections around these variables. So for example, right now, sorry for jumping around. So right now there's nothing to do things like prevent us from saying set the dollars to -3. And so if I run this new one, then now dollars is now negative $3.40. And maybe you want this to represent like actual physical dollars, not like a virtual amount. So maybe you don't want to allow negative dollars and negative cents. Well, if we had this public the old way, where we could say m1.dollars equals whatever, there's no way to prevent us from adding like negative 10 as the dollar amount. But in our new version, we can do things like when you call set dollars, we could say if new dollars is less than 0, or I can say if it's greater than or equal to 0, then we do the set over here. So it only sets the dollars if it's 0 or more. So now we can't do negative dollars anymore. If I come back here now and I try to run it, this isn't set to negative 3. It's got the default value of 0. So it prevents us. So we have the opportunity now to do things like, prevent invalid values from being sent in. It also lets us do some interesting things like if the cents, for example, let's change this to positive. If we set the cents instead of to 40, if we set it to 140, then right now it outputs $3.140, and maybe you like it so that the 140 cents becomes an extra $1.40 instead. Then now in the money class, we can say, well, if you ever go and try to set the cents over here, then we could say dollars equals dollars plus new cents divided by 100. And then cents gets new cents mod 100. So if I gave this 140, then this would take the 140 divided by 100. Since they're integers, it just becomes 1. So dollars would get itself added with 1. And then cents would become a remainder after dividing, so it becomes 40. And so now over here, instead of getting 3 and 140, I get 4 and 40. So we can put these kind of nice mappings and guards in place by doing this thing over here where your variables are always private, but then you have these public getters and setters where you can add the extra code that might do some mappings for us. So one complaint is that it's a little bit of a pain to add set and gets for everything, because a lot of the times you'll just have a set and get with nothing special in here but just return and set the variable. So it turns out that one advantage of using something like NetBeans is you can add things in here like, let's say I had another private int, some stuff, private string foo. So here I just made it some variables. In NetBeans, I can right-click and do refactor. And then there's a thing in here, encapsulate fields. And then you can pick the variables you want, like stuff and foo. And if we click these boxes, then what it does for us is it actually creates a set stuff for me and a get stuff. So I didn't have to write it myself. I can go through the little menus and it'll make this for me. And then the same thing for foo. And so it made a get foo for me. And since foo is a string, it returns a string. And then here's a set foo. So that's one of the nice things about using IDE like NetBeans or Eclipse, is it's got features like this, whereas with Dr. Java or TextPad, you have to type all that in yourself. So, okay, let's see here. There's more stuff I could cover. In my notes, I skipped over some of the stuff in my notes. I'm going to go back to some of it to say a little more about how methods work. but I think I covered enough at least to do the drill. So I know we covered a lot of stuff already. Are there questions about what we've done? Okay, and so maybe I'll stop here, and then what I have you doing on the drill is basically making a class kind of like this money class, but instead it's like a student class with number of credits. So you've got a couple different variables in here, but you have to make these same setters and getters. They're different types, and then there's another method to write that returns back the tuition fees based on the number of credits. So I think I'll stop here and let you work, and if you have questions, then let me know.